Have you ever pondered whether we're truly alone in the universe, or perhaps wondered if there's something more to our existence than what we perceive? What if the James Webb Telescope finally reveals that we're living inside a black hole? Join us as we explore this mind-bending possibility that may make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you may have seen them in science fiction films, but they are far more terrifying than that. According to scientists, black holes are regions of space where enormous amounts of matter are compressed into a tiny area. Imagine a star several times larger than the Sun, all packed into a space no bigger than New York City. The gravitational pull is so intense that not even light can escape. Scientists have been fascinated by black holes for years. These objects in space are so dense and massive that they trap light. The most widely accepted theories about black holes were predicted by Einstein's general theory of relativity. Essentially, when a massive star runs out of fuel, it collapses inward, leaving behind a dense core. If the mass of this core is several times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. It's not easy to detect black holes because they emit no light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, when a black hole passes through a cloud of interstellar matter, it pulls that matter toward itself in a process called accretion. If a normal star gets too close to a black hole, it can be torn apart, emitting X-rays in the process. Black holes also have massive effects on their surroundings. They can consume nearby stars, emit powerful gas blasts, and even influence the formation of new stars in certain regions, either speeding it up or slowing it down. But where do black holes come from? Picture stars that were once magnificent but ultimately meet their fate in a colossal explosion called a supernova. From the remnants of these fallen giants, black holes are born. Most black holes form from massive stars that have reached the end of their life cycle in a supernova blast. Smaller stars, when they die, transform into neutron stars, highly dense objects, but not dense enough to trap light. If a star is several times more massive than our Sun, it collapses under its own gravity, forming a black hole. As powerful as these collapses are, something strange happens near their surfaces. Time itself begins to distort. From the perspective of an observer far away, time seems to slow down as one approaches the event horizon, the point of no return for anything falling into a black hole. It's as if time itself behaves differently near a black hole compared to our own. Occasionally, two smaller black holes may collide and merge, forming a much larger and more dangerous black hole. If a black hole interacts with a neutron star, it creates a cosmic phenomenon that defies comprehension. Scientists have been grappling with understanding the size and nature of these massive objects for a long time. Black holes come in two main sizes, big and small. However, small is a relative term when it comes to black holes. Supermassive black holes, the remnants of monster stars, can be as massive as 10 to 20 times the size of the Sun. There could be anywhere from 10 million to a billion such black holes in the Milky Way alone, each capable of swallowing anything in their path. But there's something even bigger, truly massive black holes. These giants can be millions, if not billions, of times larger than the Sun. They exist at the centers of enormous galaxies, including our own Milky Way. They act like a vast dark void, pulling everything around them toward it. The renowned physicist Stephen Hawking dedicated much of his life to studying black holes. While some of his theories could not be confirmed due to technological limitations, there's hope on the horizon. A single scientific instrument is poised to make a massive difference, and it's called the James Webb Space Telescope, JWST. This telescope is not just any ordinary instrument. It's an engineering marvel, a true testament to human ambition. While we've launched other space telescopes before, the JWST is truly extraordinary. The JWST makes the Hubble Space Telescope, which has served us for years, look like a basic tool in the vastness of the universe. With a staggering price tag of $10 billion, the JWST required the combined efforts of NASA, the European Space Agency, the Canadian Space Agency, and over 300 universities to bring it to life. But such an ambitious project comes with significant risks. The JWST is venturing into uncharted territory, pushing the limits of what we know and exploring places we've only dreamed about. After its successful launch, NASA announced that the telescope has enough fuel to last more than twice the length of its original mission. Since then, the JWST has achieved remarkable feats, traveling over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and enormous primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has aligned and adjusted it, the telescope is nearly ready for full operation. One of the most exciting moments for the JWST came when NASA reported it had captured its first pictures of starlight. The first image was of a star named HD 8446, which resulted in a mosaic of 18 scattered bright spots from the star's light, captured by the 18 mirror segments on the primary mirror. Later, the JWST released an even more astonishing image of HD 8446, where the 18 unfocused duplicates of the star were combined into a deliberate hexagonal arrangement. Once the observatory successfully aligns the individual segments of its primary mirror, it will begin the process of stacking these 18 images into one clear and detailed view. Thanks to its cutting-edge technology, the JWST is set to assist researchers in examining the early stages of the universe after the Big Bang. This includes looking into the period known as the epoch of reionization, when the first stars formed and began to ionize hydrogen, turning it into a charged state through radiation. This period occurred billions of years ago, and studying it is only possible with the power of a telescope like the JWST. The telescope will also help scientists discover exoplanets, which are notoriously difficult to detect due to the subtle ways they interact with their host stars. The JWST's powerful sensors will be able to study the planets in greater detail, even allowing for the imaging of their atmospheres. Understanding the environments of these planets will help scientists determine which ones might be capable of supporting life. Besides studying the formation of universes, the JWST will also help researchers better understand the structure of galaxies and how matter is organized on a large scale. This knowledge will reveal how the universe has evolved over billions of years. One of the JWST's key goals is to look back at the earliest galaxies to better understand their formation and development. Scientists are also working to understand how we got the range of galaxies we see today and how galaxies currently form and accumulate. But perhaps most importantly, the James Webb Space Telescope may help us answer the ultimate question. Are we alone in the universe? And perhaps even more radically, could we be living inside a black hole? The JWST has already begun its search for answers and made a fascinating discovery. It found compounds known as polycyclic aromatic hydrocarbons, PAHs, around supermassive black holes in 3 active galaxies. These carbon-based molecules, which have ring-like structures, are found everywhere, from distant galaxies to comets in our own solar system. They are significant because they might be the building blocks of life. Furthermore, when ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument. This light can indicate the presence of hot, young stars nearby. But here's where it gets eerie. Astrophysicist Ismael Garcia Bernard from Oxford University studied 3 active galaxies, NGC 6552, NGC 70319, and the famous Stephan Quintet, located millions of light-years away. What he found in these galaxy central regions, where the black holes reign, will send chills down your spine. The radiation near these supermassive black holes distorted the PAHs, changing them into larger, electrically neutral versions. The smaller, charged PAHs vanished into oblivion. Imagine being consumed by the darkness itself. Now the ultimate question looms larger. Are we alive, or do we truly exist? Perhaps everything around us exists because of the black hole we inhabit. Could it be that the entire universe is connected, all inside a black hole? The JWST is currently out there searching for answers to these cosmic mysteries. Its discoveries may force us to reconsider everything we thought we knew about existence. The truth may be far stranger and more complex than we can imagine. As the JWST continues its mission, it will push the boundaries of our understanding, helping to answer questions that have puzzled humanity for centuries. The telescope is more than just an instrument. It's a window into the deepest mysteries of the universe. Its findings may not only unlock the secrets of black holes and exoplanets, but also provide crucial insights into our place in the cosmos. Will it answer whether we are truly alone? Will it help us discover other life forms hidden in the depths of space or in the atmospheres of distant planets? The JWST's powerful instruments are capable of probing further into the universe than any telescope before it, revealing previously invisible structures and phenomena. This remarkable machine has the potential to change everything we thought we knew about the cosmos, about gravity, and even about time itself. The more we understand black holes, the more we may come to realize how interconnected everything in the universe truly is. Perhaps we are all part of a larger cosmic story, one that the JWST will slowly begin to unravel. But with each answer comes more questions. Are we simply part of a cosmic experiment? Or are we part of something far grander, something that spans dimensions we can't yet comprehend? The JWST will be at the forefront of this inquiry, examining the universe in ways that challenge our imagination and understanding. As we venture further into the unknown, this telescope will likely change the future of space exploration. It promises to help us unlock the deepest corners of space, revealing insights into phenomena like the Big Bang, dark energy, and the true nature of gravity. It's a thrilling prospect that, with the aid of this remarkable instrument, humanity may finally uncover the answers to questions that have eluded us for millennia. As we watch its discoveries unfold, one thing is clear. The James Webb Space Telescope is a reflection of humanity's thirst for knowledge, our unyielding curiosity about the universe, and our drive to understand the unknown. It is more than just a project. It's a testament to who we are as a species, looking to the stars not just for answers but for understanding. The James Webb Space Telescope, JWST, continues its mission, and it promises to transform our understanding of the universe in ways we can hardly imagine. Beyond its ability to peer into the earliest stages of the cosmos, the telescope is also designed to answer some of the most profound questions about the nature of space, time, and existence itself. The knowledge it uncovers may not only change the way we view distant stars and galaxies, but could also challenge the very foundations of physics and cosmology. One area of great interest for scientists is the study of dark energy, a mysterious force that is driving the accelerated expansion of the universe. For years, astronomers have observed that galaxies are moving away from us faster and faster, but they don't fully understand why. Dark energy is thought to be responsible for this phenomenon, but it remains one of the biggest mysteries in modern science. The JWST is ideally suited to investigate dark energy, as it can observe the universe at unprecedented distances and depths. By studying the distribution of galaxies and the patterns of their movement, researchers hope to gain new insights into the nature of this enigmatic force and how it shapes the cosmos. Another intriguing possibility is that the JWST might help us answer one of the most fundamental questions of all. How did life begin? By studying the atmospheres of exoplanets in detail, the telescope can provide crucial information about the conditions necessary for life to exist. For example, scientists are interested in identifying signs of habitability, such as the presence of liquid water, an atmosphere with oxygen, or chemical compounds associated with biological activity. The discovery of these markers on distant worlds could revolutionize our understanding of life in the universe, suggesting that we may not be as alone as we once thought. Moreover, the JWST could potentially provide clues about the formation of life in the universe itself. By examining the molecular building blocks of life, such as organic compounds, amino acids, and other essential chemicals, the telescope might offer new perspectives on the processes that led to the development of life on Earth. These discoveries could give rise to an entirely new field of astrobiology, where scientists explore how life might arise on other planets with conditions similar to ours. In addition to studying the birth of stars, galaxies, and planetary systems, the JWST will also focus on the death of stars and the formation of stellar remnants, including neutron stars and white dwarfs. The death of massive stars is a violent and dramatic process, often marked by supernova explosions that release vast amounts of energy into the universe. These stellar cataclysms can trigger the formation of new stars and elements, enriching the interstellar medium with materials necessary for life. By observing the remnants of these explosive events, the JWST can offer valuable insights into the life cycle of stars and the evolution of elements that make up the universe. The telescope's ability to study the evolution of galaxies is another key aspect of its mission. Galaxies, like living organisms, go through stages of birth, growth, and death, and the JWST's capabilities allow it to peer into the hearts of these massive structures. It can observe galaxies as they existed billions of years ago, revealing how they evolved over time. This kind of information will not only help us understand the history of our own galaxy, the Milky Way, but also how other galaxies formed and matured. By comparing these distant ancient galaxies with those we observe today, scientists hope to uncover the processes that govern galaxy formation, mergers, and interactions. In fact, the JWST could offer a glimpse of what the future holds for the Milky Way. One of the most fascinating aspects of the JWST's observations is its ability to look deep into the future of galaxies. As our galaxy continues to evolve, it will eventually collide with the Andromeda Galaxy, an event that will reshape both galaxies. The JWST's observations of other galaxies currently undergoing similar mergers will help scientists predict how our galaxy might change during this inevitable cosmic collision. Yet, for all the technological marvels of the JWST, the ultimate impact may be philosophical. As the telescope uncovers more about the vastness of space and time, it will undoubtedly spark new debates about the nature of existence. Questions about the origin of the universe, the potential for life beyond Earth, and the fundamental structure of reality will take on new urgency. And perhaps the greatest revelation of all will be a deeper understanding of our place in the cosmos. The JWST is not just a tool for answering scientific questions. It's a mirror that reflects our curiosity and ambition, pushing the boundaries of what we know and inspiring us to explore even further. In the coming years, as the JWST continues to send back images and data, humanity will be able to witness some of the most groundbreaking discoveries ever made. The quest to understand the universe will take on new meaning as we approach answers to some of the most enduring mysteries of science. And as we look through the lens of this extraordinary telescope, one thing will be certain. The more we learn, the more we realize just how much there is still to discover. The James Webb Space Telescope stands as a beacon for humanity's unquenchable thirst for knowledge, a thirst that will guide us as we explore the cosmos for years to come.